Alrighty, folks. On question 3B, it wants me first to refer back to 3A. However, I'm going to start with cubing this problem once again. The important information to circle is any vocabulary words, so I see construction. And that's kind of the main thing here. The directive is which of the reasons listed contribute to providing the validity of the construction. There is no verb to box, and I guess the word once is unnecessary. So, as I previously mentioned, a good strategy is to always draw a line or a diagram when possible. Luckily, it wants me to refer back to 3A, which once again was this image of two lines that are parallel. So the construction of a parallel line through a point. So here's what this looks like. And if I were to just imagine this line being extended down, it looks like I have two parallel lines being cut by a transversal. So because that is what's happening on this question over here, I'm just going to draw two parallel lines. I put in these little additional arrows to show that those lines are parallel and that they're being cut by a transversal. And I recognize that there's a total of 8 angles that are formed. And I'm just going to read through the options and see which of these options would make this construction prove that these lines are parallel. So option A says when two lines are cut by a transversal and the corresponding angles are congruent, the lines are parallel. In this case, angle 1 corresponds with angle 5, and that's saying if these two angles were congruent, the lines are parallel. That seems to be true, so I'm going to leave this option open and just make sure that B, C, and D are not true. Option B says when two lines are cut by a transversal and the vertical angles are congruent, the lines are parallel. Well, once again, option B is true regardless if there's two parallel lines or not, because angle 5 and angle 8 are vertical angles, and this happens regardless if there was that top line there or not. So the fact that these two angles are congruent is just by definition of vertical angles, and this is true regardless if the lines are parallel or not. So this is not true for the validity of the construction. Option 3 or C says the definition of a segment bisector. Once again, a segment bisector, if you have a segment, let's say segment A, B, let me erase these arrows since we're talking about a segment. A segment bisector is a line or array that goes right through the midpoint of that segment. That is not what is happening in this scenario here, because these lines can be extended forever, so we don't quite know where the midpoint is. So option C does not give the validity of the construction, and option D mentions an angle bisector. If we had an angle ABC, the angle bisector is a line or array that splits this angle into two congruent halves. Here, this would mean that any of the adjacent angles need to be congruent, which is not necessarily true in this picture. So option D does not work. So the only thing that proved that the lines are parallel is if corresponding angles are congruent. And that completes question 3B.